Just south of Japan, beneath what looks like an empty stretch of ocean, lies the scar of one of the most powerful eruptions in the country's history. 7,300 years ago, this hidden volcano didn't just erupt. It erased landscapes, buried entire regions in ash, and shattered an ancient culture. Then it vanished beneath the sea. For thousands of years, it has been silent. Just calm water above a collapsed supervolcano. But now, that silence is breaking. Scientists have discovered something massive forming deep inside this submerged caldera. Slowly, quietly, the system is rebuilding itself from the inside out. And that raises a disturbing question. What happens when a supervolcano that once devastated an entire region starts coming back to life? The supervolcano we are exploring today is the Kikai Caldera. To understand Kikai, you have to first understand the forces that built it. Japan sits on one of the most complex tectonic boundaries on Earth, where multiple plates collide, grind, and dive beneath one another. South of Kyushu, the Philippine Sea Plate is being forced beneath the Eurasian Plate along the Ryukyu Trench. As it descends into the mantle, it releases water and volatile elements into the overlying rock, lowering its melting point and generating magma. That magma doesn't stay deep, it rises. Over thousands and millions of years, it feeds chains of volcanoes that stretch across the region. This is the Ryukyu volcanic arc, and Kikai sits directly within it. But unlike typical volcanoes, Kikai is not defined by a single cone. It is defined by collapse, by the aftermath of something far larger. A caldera is what remains after a massive eruption empties a magma chamber so completely that the ground above it collapses inward. And Kikai is one of the most dramatic examples of that process in Japan. The Kikai Caldera is roughly 20 kilometers wide, partially concealed beneath the waters of the Kagoshima prefecture. Only fragments of its existence break the surface, most notably Satsuma Yojima, a sulfur-rich island where volcanic gases still seep into the air, hinting at the immense forces below. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Around 7,300 years ago, Kikai erupted in what is now known as the Akahoya Eruption. It was not a normal volcanic event. It was a super eruption powerful enough to rank among the most significant eruptions in Japan's geological history. The eruption blasted enormous volumes of ash and gas high into the atmosphere. Pyroclastic flows, superheated avalanches of gas, ash, and rock raced outward at terrifying speeds, obliterating everything in their path. What made Kikai even more unusual was its interaction with the ocean. Some of these flows traveled across water, skimming the surface and extending the destruction far beyond the immediate volcanic zone. Ashfall blanketed vast regions of southern Japan. The environmental consequences were severe. Forests were destroyed, ecosystems collapsed, and the climate may have been temporarily affected. Archaeological evidence suggests that the Jomon culture, which had thrived in the region, suffered major disruption. Settlements vanished. Cultural continuity was broken. Whether the eruption caused widespread migration or localized collapse, its impact was undeniable. When the eruption finally ended, the magma chamber beneath Kikai had been so heavily depleted that the ground above it could no longer be supported, and it collapsed. The collapse created the Kikai Caldera, a vast depression roughly 20 kilometers wide. Much of it now lies beneath the ocean, making it difficult to visualize compared to land-based calderas like Yellowstone caldera. But its scale is comparable. The edges of the caldera form a rough ring, parts of which rise above sea level as small islands. Among them is Satsuma Yojima, a volcanic island that continues to emit gases and heat, serving as a visible reminder that the system below is not entirely dormant. For thousands of years after the eruption, Kikai appeared quiet. There were smaller eruptions, localized activity, and ongoing geothermal processes, but nothing approaching the scale of the Akahoya event. To the outside observer, it might have seemed like the volcano had spent its energy, that its most dangerous chapter was over. But volcanic systems do not die so easily. For millennia, Kikai remained in what geologists would describe as a post-caldera phase. After a super eruption, the magma system beneath a volcano can take thousands of years to reorganize. The chamber that once fed the eruption is partially emptied, fractured, and destabilized. Heat remains, but structure is lost. Over time, however, the same tectonic processes that created the system continue to operate. The subducting plate continues to deliver material. Magma continues to form. Slowly, almost imperceptibly, a new reservoir begins to take shape. This is the phase Kikai appears to have entered, and only recently have scientists been able to see it. In the last decade, Japanese researchers began conducting detailed surveys of the seafloor inside the Kikai Caldera. Using advanced sonar mapping and submersible technology, they uncovered something unexpected. At the center of the caldera, they found a massive lava dome. This was not a remnant of the ancient eruption. It was new, formed long after the caldera collapse. Measuring roughly 10 kilometers across, it is one of the largest known lava domes of its kind. Its existence changes the story entirely. A lava dome of that size requires a sustained supply of magma rising from below. It cannot form without an active system feeding it, and its scale suggests that the process has been ongoing for a long time. In other words, Kikai is not just active, it is rebuilding. The lava dome is only the most visible sign of a deeper process. Beneath it, scientists believe a new magma reservoir is forming. Seismic studies have revealed zones beneath the caldera where seismic waves slow down, a classic indication of partially molten material. Gas emissions from Satsuma Iojima show chemical signatures consistent with fresh magma rising from depth. Together, these lines of evidence point to a system that is actively recharging. If Kikai were to erupt again on a large scale, the sequence of events would likely be both complex and devastating. It would begin deep below the seabed, where pressure builds within the magma chamber. Over time, fractures would form, allowing magma to rise. Smaller eruptions or gas releases might occur first, but these could easily go unnoticed due to the depth of the water. Then, if pressure continues to increase, a critical threshold could be reached. A major eruption would likely involve rapid magma release, interacting violently with seawater. This interaction can produce explosive steam-driven blasts, amplifying the eruption's power. Columns of ash and gas could punch through the ocean surface and rise into the atmosphere. If enough magma is expelled, the structure of the caldera could collapse again, triggering a massive displacement of water. This is where the danger expands beyond the volcano itself. A collapse event could generate tsunamis radiating outward from the caldera. Coastal regions of southern Japan, including parts of Kyushu, could be struck with little warning. Depending on the scale, waves could travel across the Pacific, though their intensity would diminish with distance. Meanwhile, ashfall could disrupt air travel, damage infrastructure, and impact agriculture across Japan. Even a smaller eruption could have significant regional effects, but a full-scale caldera event would be something far more extreme. A multi-hazard disaster combining explosive volcanism, tsunamis, and widespread environmental disruption. The question that naturally follows is whether Kikai could produce another catastrophic eruption. The answer is complicated. On one hand, the presence of a growing lava dome and active hydrothermal systems clearly indicates that magma is accumulating beneath the caldera. This suggests that the system is in a recharging phase. On the other hand, super eruptions are extremely rare. They occur on timescales of thousands to tens of thousands of years, and not every recharge cycle leads to a catastrophic event. Scientists studying Kikai emphasize that while the system is active, there is no evidence that a super eruption is imminent. The magma chamber may still be far from reaching the critical volume and pressure needed for such an event. However, the uncertainty is part of what makes Kikai so important, because unlike many terrestrial volcanoes, submarine systems are harder to monitor. Signals can be muted or delayed. Changes happening beneath the seafloor are not always easy to detect in real time. This means that understanding Kikai is not just about predicting one eruption, It's about improving our ability to detect and interpret the early warning signs of large-scale volcanic activity. Kikai is an evolving system, slowly rebuilding itself beneath the ocean floor. The same processes that led to the catastrophic eruption 7,300 years ago are still at work today, gradual, persistent, and largely invisible. And that is what makes it so important to watch, because the most dangerous systems are not always the ones that are loud and obvious. Sometimes they are the ones that stay quiet until they don't.